Welcome to this course on polymer chemistry. I am Dibakar Dhara. I belong to the Department of Chemistry of IIT Kharagpur. In this course, I plan to cover the following topics. At the start, I will be giving you a thorough introduction about the polymers, which includes the classification, nomenclature and perspective of molecular of polymer molecules. Then I plan to cover in details various polymerization processes. I will talk about the kinetics and the mechanism of different polymer processes, which includes step growth and chain growth polymerization. I also will cover copolymerization, especially the kinetics of free radical copolymerization, and then I will also cover other important polymerization techniques such as ring opening polymerization and coordination polymers. In the characterization, I will talk in detail about the thermodynamics of polymer solutions and then polymer chain dimensions, and I also will cover in detail about various methods for measuring molecular weight of polymers. And then I will cover important polymer properties and how the structure of polymer molecules correlates to these properties. I will also cover both the chemical structure as well as physical structure of the polymers and how it relates to the polymer properties. I will cover in brief the reaction of polymers, which include polymer degradation, stabilization and also polymer modifications, and at the end I plan to brief you about few new topics and special topics and new developments in polymer chemistry, and at the end I will complete with a summary of this course. Now, after learning what are the topics we plan to cover in this course, let us introduce polymers to you. What are polymers? We listen everywhere about the polymers, but what are polymers? In a very simple term, in a single sentence, polymers can be defined that they are large molecules. That is why sometimes they call macromolecules synonymously. They consist of many repeating structural units. The term polymers derived from Greek words poly and meros. Poly means many and meros means part. If I want to just show you pictorially or schematically, this is the representation of polymers. You have these structural units monomers, and on polymerization it gives you a linkage between the polymers making a large molecules. So, you get a polymer. For example, you have ethylene here, and in this side after polymerization you have polyethylene. In this case all the monomers are same. So, we name these polymers, we term these polymers as homopolymers. Polymers can be made from more than one monomers as well, different monomers just showed in pictorially in two colors, and in that case you get a polymers consist of two different structural units, and we call them as copolymers. To just give you an example of copolymers, I have a molecule like styrene, and I also have a molecule like methyl methacrylate. Now, these two can be polymerized to give you a polystyrene co-MMA. This is a copolymer of polystyrene and methyl methacrylate. Now, This term copolymers are used generally when you have a polymers which are synthesized from two different monomers, where the monomers can be polymerized independently, which means in this case styrene as well as the MMA can be polymerized to individually can into polystyrene and polymethyl methacrylates. There is other type of polymers which are also synthesized from two different monomers. For example, if I take example of terephthalic acid and ethylene glycol. I have n molecules of this, which on polymerization gives you a polymers which is known as polyethylene terephthalate. We get these PET bottles, they are made of this polyethylene terephthalate. So, in this case this polymer PET is also made from two different monomers, terephthalic acid and ethylene glycol, and we make a polymer, but generally we do not call this polymer as a copolymer whenever, because as I said earlier, this monomer terephthalic acid or this ethylene glycol cannot be polymerized independently by or individually. This terephthalic acid cannot be made polymers by itself, or a ethylene glycol cannot be made polymer by this process. If we have say more than one diol, in this case ethylene glycol and say butynyl glycol, that case we will have a mixture of two structural unit where you have terephthalic acid and ethylene glycol, and also a terephthalic acid and butynyl glycol. In that case we call this, or we name these polymers as a copolymers. So, just to repeat about this copolymers, generally we use the term copolymers where a polymer is synthesized from two different monomers, where the monomers are or can be made to a homopolymer individually. There is another case where polymer is made from two different monomers, but in this case we do not call this as a copolymers, because the constituents monomer usually cannot be homopolymerized independently by the same process. And when we make polymers, we invariably land up in a distribution of molecular weight. While a polymer is a high molecular weight, but it also gives you a distribution of molecular weight. That means it has several length. The polymer mixture is consisted of different molecular weight chains, and this is this high molecular weight of polymer which gives you, or which enables a polymer to have these useful properties where for which the polymer is known for. For example, it gives you high tensile strength, impact resistant, toughness, melt viscosity, and so on. Now, you might ask me why, what is the reason this high molecular weight help in giving a polymer this superior properties compared to the small molecules. Let us look at this cartoon. If you compare a collection of small molecules or short molecules like a sugar and a long molecules which is a polymer sample, this each individual colors, individual chains represent a individual molecules in this case as well. Now, this is a case where the individual molecules are small in size, they are not entangled with each other. So, given a stress from outside, they can be separated easily. In other words, these small molecules behave independently. If I just give you a example of real life, say I have taken a bowl of rice and you want to take out rice with a spoon, you can easily take out because each individual rice units behave independently. So, you can easily take out rice from a bowl by a spoon. Whereas, in case of polymers, because of the large size and its flexibility, they are present in a mixture in an entangled well. That means, the polymer chains are entangled with each other, and as they are entangled, they cannot be moved independently with each other. For example, real life example, if I have a bowl of noodles and I ask you to take a spoon, 1 spoon of noodles, you cannot independently take out noodles with a spoon because they are entangled. So, chains comes together. So, once you take out the noodles, you get a chunk of polymer or pieces of noodles which you take out. So, in this case where it was very easy to deform or a set of small mixture of small molecules, in this case because of the large molecules, it is difficult to deform a polymer molecules, which gives you high viscosity, which gives you the high strength of the polymer molecules, high impact resistant, high toughness, and all other good properties of polymer samples, and that is why polymers is so popular nowadays. Okay, coming to the more definitions relevant to our course or polymer chemistry as such. Monomers we talked about several times. Monomers are molecules from which polymers are made. They must have at least functionality of 2. That means they can be reacted at least from 2 sides. For example, we talked about styrene molecules or ethylene molecules, which means they can be extended from 2 sides. If you have a molecules which have only one functionality, for example, instead of ethylene glycol, you have a phenol molecules, then once this OH of phenol is reacted, the chain does not go, so you cannot make a polymers. So, for making a polymers, you require monomers which have at least 2 functionality in them. Repeating units, it's a structure, a polymer is formed from repeating units, which means that when you write a polymer structures, the repeating unit is the unit which gets repeated. For examples, I talked about the ethylene molecule in or say a simple example of say polystyrene molecule. This is styrene, and when it polymerized, it gives you polystyrene. In this case, this is the unit which is repeated, which means and this is the repeat unit for polystyrene case. Now, if I go back to the example I gave in the few minutes back, in this case, for example, for polyethylene terephthalate, this is the unit which is represented in the bracket with the subscripts of n. This is the units which gets repeated. So, if I want to write a structure of PET, then I can take these units and put one after one to build the polymer units or the polymer molecules. So, just to clarify one more time, in case of styrene, we have the styrene unit as a repeat unit, and in case of PET, you have this unit have a with a repeating unit. We talk about oligomers. Oligomers are, during the process of polymer synthesis, you get the small chain units which consist of 2 monomers, 3 monomers, 4 monomers and so on, dimers, trimer and tetramer, and these are called or termed as oligomers. Now, you can ask me till when, till what time we call a molecule as a polymer or a oligomer, whether it is after 10, 11, 12, 20, 50, 100, after how many repeat units you call a polymer as a polymer, and before that you call as a oligomer. Now, it depends upon different polymers. The easiest way to think a molecule, a long molecule as a polymer, not a oligomer, if you add another unit, repeating unit, or you take out another unit, and by doing this addition of one unit or taking out of a unit, if the property of the polymer or the molecule does not change, you call it as a polymer, but if change significantly, then you still call this as a oligomer, and that will depend on the chemical structure of the polymer. So, some cases, if you increase from a repeat unit number from 20 to 21 or decrease from 20 to 19, you might see there is a change in the property. You cannot call that chain as a polymer, you have to call that as a oligomer, whereas in some cases, some cases you do not see any changes, say after 20 to make 20 to 21 and 20 to 19, then you call that as a polymer. We define degree of polymers. It is the number of structural units present in a polymer molecule. Now, what is structural units? Now, let us talk about the example I just showed you before. In the case of polystyrene, this is repeating unit and this is also a structural unit, because structural units is the unit which is derived from a monomer. So, in this case, this unit is coming from a single monomer of styrene, where the double bond is replaced by a single molecules. So, in this case, the number of repeating units RU repeating units is same as number of structural units, SU is structural units. Whereas, in this case of polyethylene terephthalate, individual monomers which are coming here and making the polymer, they are called structural units. So, in this case, if n is number of repeat units, then each repeat unit consists of 2 structural units, because in this repeat units is derived from 2 monomers, one terephthalic acid unit, one ethylene glycol units. So, whereas in earlier case the number of repeating units were same as number of structural units, in this case number of repeat units is actually half of the number of structural units. So, when you define degree of polymerization, it is the number of structural units, not the number of repeat units present in a polymer. So, in this case, if the molecular weight of each styrene is m and you have a polymer with n number of repeat units same as structural units, then molecular weight of this polymer would be m multiplied by n. Now, what happened in this case? In the case of PET, for example, if I take the molecular weight of this as m1 and this as m2, then how do you get the polymer molecular weight? How did they define the degree of polymerization? Is the number of structure unit. So, in this case the polymer molecular weight will be degree of polymerization multiplied by the average of these two monomers minus the water molecules which have been eliminated. I will show you real example in coming pages, so that it will get clear little bit more if it is not clear already. So, let us see whether it get clarified to you in this cartoon. In this case of styrene, you have polystyrene in this case. So, structural units is same as repeat units, and in this case whether you have a say example of polyterephthalic acid PET, terephthalate PET, the polymer is derived from two different units, then the repeat units is this, whereas this consists of two structural units. So, if I take this part, then this consists of 4 structural units, but only 2 repeat units, and as I said, degree of polymerization is number of structural units, and the molecular weight of polymer molecules is degree of polymerization, that means number of structural units multiplied by the average structural unit. Okay. Now, before going forward, let us clarify one thing. More often or not, in commonly polymers are referred as plastics. People ask for banning plastics, plastic bag, plastic shoes, plastics bottle, everything. Most of the applications of polymers are referred to as the application of plastics. Now, there is a subtle difference between the term plastics and polymer. Polymers are the molecules which we synthesize from the monomer. Now, they are individual molecules or a mixture of molecules, but we do not use, when you synthesize a polymer from in the lab or in a plant, we do not use, seldom use as the polymers as synthesized. In most cases, what happened, we add some additives like pigment, stabilizers, and then process that polymer mixture, polymer with the mixture, to turn this polymer into a practical product. So, if I talk about PET bottle, when you synthesize PET in the lab, and that is not a plastic material. But when you take a PET molecule, polyethylene terephthalate molecule in the plant and then mix it with stabilizer and other things and form that bottle, that is called plastics. Plastics has also have more scientific definitions, which we come later, but at this point you must remember that plastics are made of polymers, but not all polymers are plastics. Like there are several other applications where polymers are not used as plastics. Okay. So, when you talk about, but in common man, whatever they see is applications of polymers, they see in daily life is a plastic, and applications are visible as a plastics applications. So, that is this common term, that is why this common term is appearing. Okay. Just one more time, plastics are polymers, but not all polymers are plastics. Now, just knowing what are polymers, what are plastics, and what brings the good properties in polymers. Now, why you will ask me why you need to study polymers, why you should be interested in studying polymer or polymer chemistry. Now, if you think yourself, or if you read magazines and talk to the older people, then you will find that in last century, whatever new material development has happened, polymers will rank as one of the top. So, in last century, polymer is one of the biggest success in terms of new material development, and as a result, more and more applications are existing or coming up where these polymers are replacing the conventional materials like metals, glass, wood, and so on. For example, I am wearing a spec. Now, earlier few years back, for a decade back or so, this spec used to be made from glass, but nowadays you will hardly find any spec is made of glass. They are all made of either polycarbonates, or the cheaper ones are from acrylics. There are hundreds of such example I can give, maybe I will give in a later classes, but I hope you are convinced that polymers is finding applications in several places. And nowadays, when we talk about a scientist or a developer, application specialist, we think for a new material application, first thing comes in the mind is a polymer, and more often not, a polymer becomes very often the material of choice for new applications. So, I hope you are convinced that polymers are a useful material and replacing the conventional materials. If you are still not convinced, if you think what you do once you wake up from bed, you take a brush which is made up of plastic material, you use the toothpaste which contains polymer molecules, you take foods are also having natural polymers, the containers sometimes we use disposable plastics, then you wear shirts, clothes which are made of polyesters, cottons, these are all examples of polymers. Then you come to office by a car or a bus or a cycle, there are hundreds of polymer goes in those applications. You name, wear shoes, everything. Now, you can argue me that these are very common materials, and these are no need for namely development work for this. So, you do not need to study polymers, because the knowledge or technical knowledge for these common applications are well established. But if you think about examples of polymer like a artificial valve which is made of polyethylene, talk about an oxygenator which is used during a open heart surgery, or talk about applications in car headlamp, aircraft windows, and several high end applications like very high capacity DVDs. Now, these are also application of polymers which it does not come to your mind immediately, but like this there are hundreds of very high end applications of polymers. For example, polymers are used in medicine as a drug delivery vehicle, as a conjugation with drugs, molecules, and so many. So, in this case you require a definitive knowledge about polymers which will enable you to develop or innovate new polymer molecules or new polymer applications. Now, why people use polymer compared to these conventional materials or traditional materials? There are some definitive advantages. For example, I just gave you example of this PET. Now, when you use a plastic material like polycarbonate compared to a glass, this becomes much lighter. It gives you a lot of comfort than the glass. Now, because of the lighter weights, polymers used heavily in transportations like car, automotive, in trains and all these things, because the light you travel, that will consume less fuel. So, this is one of the most important advantages of using polymers, which gives you excellent strain to weight ratio. It gives you design flexibility. There are, and also very the option of giving you modern styling. You by a cheap processing, you can take the polymers which is comes in after from the lab or in a plant, and you can do the polymer processing do a process and make or give that polymer very nice shapes of your choice and give good style, which is not possible with the traditional materials like glass and metals. Polymers are most cases thermal insulator, which enables polymers to use in electronics industry, and unlike the conventional materials like wood, metal, they are optically clear, which enables application of polymers in media and optical devices. And one more important, that there are so many polymers available in market that you can choose a definite polymer for your particular applications, so that you do not have to limit it with number of polymers available. There are so many polymers available now in market, so it gives you the option of choosing a definite polymer, a particular polymers for your choice of applications. And of course, not more often than not, it comes with a lower cost. Some polymers are of course very costly, because that gives you very good performance, but more often not the polymers comes with a lower cost. Now, before I come to the introduction of polymers or polymer chemistry, I just want to give you a big picture, a view on the top, a bird's eye view from how you look at polymers. Different stages, life stages of polymers, and how it get transformed, where is the end use of polymers. So, you have a polymer molecule which you synthesized in the lab, Now, when you synthesized, you get it in solution or in a bulk. So, you have a polymer which is prepared in the plant, which is coming either in solution or in a bulk. Sometimes it come other form as well, like in emulsions. So, if it is solution, you have to take out the polymers from the solution in a powder form, and if it is in the bulk or in a melt form, you can use as such. And if it is in emulsion cases, like some cases it is in emulsion, so you can use the emulsion as such. Now, how do you get these polymers? There are some polymers or few polymers which comes from natural sources, like polysaccharides, cellulose. Now, more often not, these natural polymers, the polymers which comes from natural source, are very useful. So, in most cases, to find a polymer, these polymers are synthesized in a plant from raw materials, which are monomers, by the process which are termed as polymerization. So, you have polymers which you can get from natural source, but in majority of cases a polymer is synthesized from raw materials, monomer, by a process called polymerization. Where from do you get these monomers or the raw material? Most cases you get from petroleum resources, ultimately from a crude oil, or in some cases you also get monomers from renewable resources or bioresources. But as I said, most cases synthetic polymers are prepared or synthesized from monomers which are derived from petroleum resources. So, now we have know where from a polymer is made. Now, you have to take the polymers towards application side. There are minority of polymers are taken to the applications where polymers are used along with the other ingredients, like in detergents. In a detergent formulation, you have surfactant, polymers and other ingredients. If you talk about say eye drop, you have polymer in aqueous solutions with salt and other ingredients. So, in this case, these are the applications which are or where the minor, it's a minor fraction of polymers go in, where polymers are used in a mixture, in a solution or some other form, where the polymers is either a active ingredient or it just act as a support role, like enhancing the viscosity or viscosity enhancer and so on. But in majority, the major volume of polymer comes out from the manufacturing plants, goes in the application where polymer is the major part, is the application of polymers is major. You can have the other ingredients along with the polymer, like the stabilizer, fillers or pigments, but it is the polymers which is the major ingredient, and the other additives acts as a support which either enable the polymer to have better performance or not. So, in that case, what is done, the polymers as comes out from plant is taken through a step, a polymer processing steps, which are commonly called compound, where the polymer either in a melt form or in a powder form is mixed with the required additives or property enhancing fillers, or sometimes with other polymers as well to make polymer blends, and you get an intermediate product. It is like pellets, we call this as resins. You might have seen these granules or pellets yourself in sometimes in the market. And if the final applications does not require very complicated geometry, then in this process itself you can make the final product. For example, like sheets film, where in this processing step itself the polymers are taken and the additives or fillers are added, and it is given a shape of the final products like sheets and film, etc. But this is not the major application, this is the minor applications. In most cases the polymer manufacturer makes this as a intermediate products and they sell is to its customer who makes the final product. And once the polymer and these pellets are supplied to the equipment manufacturer, they do a processing steps to give you or to give the final shape, design fabrication step or in finishing shape, and you get the final products which gives you the which goes into the final application. I will give you examples which will clarify these points more. Once the final application is done, the life cycle of the polymer does not end. Once the application of over, polymers become a waste. Now, it is very important, is as important as the earlier steps, that we have a very good waste management system by which we can either reuse or recycle the polymers, and if you cannot recycle or reuse the polymers, then this waste of the polymer waste has to be handled very carefully, so that it does not pollute the environment. So, if I repeat these life stages and various transformation steps, you have a monomer, which most often we get from petroleum products, and from monomers, by doing a step called polymerization, we get the polymers in the plant or in the lab, either in solution or in bulk or in some cases in emulsion form. If it is solution, you have to take out the polymers as a powder form. So, you have now the polymers. In a minority of applications, these polymers are taken and added to other ingredients, like the examples I gave in detergents. But in major cases, the polymer is mixed with the other ingredients like additives, pigments, stabilizers, and it is by a process called polymer processing or compounding, and it is transformed to granules or flakes or pellets to form intermediate product. These intermediate products are taken by the equipment manufacturer, and by doing another processing step, for example, injection molding, they give the proper shape of the final applications where this polymer goes in. How the polymer industry works? Now, if we talk about the big polymer manufacturers like DuPont, Dow Chemicals, SABIC, Bayer, they are manufacturer of polymers. They get the monomers from other source, or they might make themselves as well. And they, after making the polymers in the plant, they also do these steps themselves, form this intermediate product and then sell it to some original equipment manufacturer, which do this processing step, molding step, to make the final product, which goes into the final applications. Now, let us come to a specific example. For example, if I take a car headlamp cover, the cover of the car headlamp is nowadays made from polycarbonate material. Polycarbonate is synthesized from two monomers, bisphenol A and phosgene. To give you polycarbonate. Now, how do you get, how this is produced? This BPA molecule, this is produced from phenol and acetone, and this is produced from coke getting oxidized to carbon monoxide, which on react with chlorine gives you phosgene. Where from this phenol comes from? It comes from cumene plus acetone. Where from this cumene comes from? This comes from petroleum products, which is eventually comes from crude oil. You take this polycarbonate as synthesized in a plant or in a lab, add these additives, pigments, etc., and do a compounding strips, and you get PC pellets. You sell these PC plates to a equipment manufacturer, which will make, say, injection molding and make the headlamp cover at OEM, which will be sold to the car manufacturer. Let us just go back to the earlier page and repeat this. Now, a company which makes polycarbonate, which sells polycarbonate like say Bayer or Sabic, they make this process definitely. They synthesize the polymer in the polycarbonate in the plant themselves. They can source the monomer at any stage. They can buy BPA and phosgene, they can buy phenol and make BPA themselves, or they can buy a cumene and they can make phenol, from which they can make BPA and then PC. They also do this step compounding step themselves. Now, after making this pellet, they sell it to original equipment manufacturer. This original equipment manufacturer buy these pellets, polycarbonate pellets from any of these big companies, and they mold it to give a form of a headlamp cover, which they then supply and sell it to a car manufacturer, who assemble this headlamp along with other things and have this product in the market. So, this gives you an idea about a different stage of polymers and how the industry works. There are some smaller industries which make custom polymer products. These are the examples of big polymer industry, where the companies make the polymers in very large quantity. But for the applications where polymers find minor, like the examples I said, where polymers are synthesized and added as a active or secondary ingredient in other formulations, those polymers are typically made by the smaller companies, and they are taken they are synthesized by the smaller companies. Now, what is the present focus of polymer research? If I go back to the earlier slide, as I said that most of the current synthetic polymers are made up from monomers, which are ultimately sourced from petroleum products. As there is a increasing interest to make polymer from the monomers which are not sourced from petroleum products, because on using the polymers or making polymers from petroleum, there is a fear of depletion of petroleum resources. So, current focus in polymer research is to make monomer and subsequent polymers from a natural sources, which could be a bio source or a source which can be renewed, or the force renewable resources. There is a focus also make this polymerization process green or environmental friendly, where you avoid use of these toxic chemicals and gases like solvents and other things. There is also emphasis of making new polymers of complicated structures, which will find applications in newer, especially in medicines. And also this is a continued research interest, where you take existing polymers and add additives, fillers, newer additives, fillers, or different processing step, improved processing, improved polymer processing step, where you make this different improved application of or newer applications of the existing polymers. And of course, there is a very highly important, the more importance given especially from the government side about the waste management of polymers, especially recycling of polymers, and find the ways where you can reuse the polymers. And of course, there is a need for research how to properly manage the polymer waste. Okay, with this I will stop this class. In the coming class, I will start with classifications of polymer. Just to repeat what I covered in this class, we talked about the definition of what are polymers. Polymers are large molecules which is made from repetition of structural units. We also learned why we should study polymers. Polymers, as you by now convinced, that find applications in conventional applications as well as very newer applications, very high end applications. And you also learned why nowadays polymer is used more and more applications, what are the good properties of polymers, and why polymers are different, why polymers are get what are the structural features of polymers gives you these improved properties. And then we also learn the big picture, what are the different stages of polymers, and then how the polymers are transformed from one stage to another, and ultimately how the polymer industry works. And then we talked about finally about what are the important research areas in currently researcher focusing in polymer chemistry. Okay, we will start in the next class, continue the introduction, and we start from the classification of polymers.